Hey, I'm Eric, and I'm one of the creators of Sequin. And this video is all about the ways to capture changes from your Postgres database. A couple months ago, we wrote a blog post that explained all the ways to capture changes in Postgres generally. Check it out. But recently, we wrote an updated post that explains all the ways to capture and react to changes in the Supabase platform, because Supabase adds a couple amazing new ways to do that. This video is a companion to that blog post, and it's going to explain all the ways to capture the changes from a Supabase project and explain when you may or may not want to use those different methods. So let's dig into it. The first step is really to get a Supabase project going so I can show you some real examples. This is a completely empty Supabase project, and we should use their new tool, Postgres.new, to fill it with a schema. So let's give it a try. So to get started, let's just describe what we want. I think a really easy project here is just a classic e-commerce customers orders example. So let's describe the schema we want. Perfect. That looks like exactly what we need. So we have a product table, we have orders, order items. We select all this. That looks great. Go over to Supabase, SQL editor, paste that in there. We now have tables, and let's get those mock products in there. Can you fill it with some fake data in the products, the Apple products? Wow, that's just so cool. Yeah, you'd spend so long doing just little things like this before. So fantastic. So huge fan. So now when I go in here, voila, I have some MacBook Pros in my database. So first things first, let's talk about Postgres triggers. Postgres, you can trigger a Postgres function when an update, insert, or delete happens on a specific table. It's really helpful specifically for inter-database triggers where you want to update one other table due to the actions of another. It provides exactly once guarantee. So if a transaction happens that will initiate that trigger, that function will run. And if that function can't run, the transaction will be rolled back. So that's a huge benefit of Postgres triggers. Let's say we want to write a trigger that anytime the product inventory for a product falls below 0, it sets the availability to false. I could write this by hand, but we live in an age where these LLMs do this so well. Write a Postgres trigger that sets product catalog availability to false if product inventory hits 0. This is the trigger. It's saying check inventory after an update happens on the product inventory table at any row, then it triggers this function. So basically, if there's an update of any kind on a row in the product inventory table, it's going to run this function. If the new quantity is 0 on the product inventory, then it sets availability to false on product catalog. Otherwise, it sets it to true. So that's perfect. Now I'm going to copy this SQL statement and head over to Supabase. I could have gone to database and manually done these things in the functions tab and in the triggers tab. But because we live in an LLM world, I'm just going to paste that in there. They'll be created. Now we can test that out. In the product catalog, if I set the inventory to MacBook Pro to 0 in the inventory table, this should flip to false. If I set this to 0, then I should come over here and it's false. The trigger works. If I go back and I put that back to 30, great, it's true. The transactional guarantee on triggers is amazing. I know no matter what changes that row, that the availability is going to update correctly. The downside, first, if there ever is an error or issue, I know transactionally it'll roll back, but it can be a little hard to debug and figure out what's going wrong. The second is I have to manage this function in my database. And last but not least, the impact of this trigger can only happen in the context of my database. Supabase has made it possible for a trigger to do something outside of the context of the database through webhooks. Let's dig into that functionality. Now, let's say we want to trigger a webhook to fire anytime a new order comes in so that when that order is processed, it updates the inventory. We'll do that through a webhook, and then we'll actually write the business logic in a Supabase function. So let's first get the webhook to fire. So I'm going to create a hook, and we want this webhook to fire anytime an order is created, the insert or update. And just to begin to show how this works, let's just have it fire a standard HTTP request first, and then we'll convert it into a Supabase function. So to see how this works, there's a great site, webhook.site, that just gives us a simple endpoint to handle the webhook and show us the payload. So we'll use that as the base URL, and we don't really need anything else. Let's create that webhook. Under the hood, it will have created a new trigger, as you can see here. Back over to our favorite LLM. Can you create a mock order? Perfect. We have a mock order. Let's run it. So if we go back over here to Supabase, run that mock order, we should see that a new order has been generated in the database. Okay. We have a new order right here. And if I go over to my webhook, I have order 6 right here, customer ID, the total amount, right? So the full payload from this order line has been delivered to the webhook. Now we would want to process this webhook to properly update the inventory. And this is where we would call on a Supabase edge function. So if I go back over to the database, I check my webhook. As you'll recall, right now it's just triggering an HTTP request, but I could have it trigger a function. I actually already have one here called process order. It's a little bit out of the scope of this tutorial to explain how to set up those functions, but I'll show you what this function does. Just TypeScript, and it's going to take in that webhook payload, right? Confirm that it's gotten that payload, extract the order ID, go in and pull out the order items associated to that order. And for each one of those order items, extract the product that was on that item, and then update the quantities in the inventory table. Now, of course, you could do something like this through a Postgres trigger, don't get me wrong, but moving it into my workflow easily to extend with more functionality. For example, let's say after all of this happened, I wanted to send an email to the user. That could all happen here very easily. I'm not sending an email from my database. I call that function as a curl. You'll see inventory updated successfully. Now if I go back over into my database and I check on product inventory, you'll see we have some incremented inventory quantities. There's a couple things to keep in mind with webhooks. It's an at most once guarantee. We know that the webhook will hopefully fire, but it's not a promise. And if it does fire correctly, there's no guarantee that the function is going to process it correctly. The second is you just don't have great observability as it's happening and what exactly the issues were. So this is why you may not love the webhooks at scale. Let's dig into the next option, and that's Supabase Realtime. Now, Supabase Realtime is a bit of a departure from the prior two because while Postgres triggers are all about making changes within the database, and database webhooks begin to extend those triggers to trigger code outside the database, Supabase Realtime is really about allowing web clients to get notified about changes in the database. So in particular, it's that if one row changes in the database, everybody using the e-commerce store can get notified about that change. Just have a simple website, just shows the products catalog, right? And so if we look at the code, it's basically pulling in Supabase, and then it pulls in the Supabase catalog, right? The availability. And then it displays those products beautifully, as you can see here in raw, beautiful text. Here, we're pulling in the Supabase client, and we're doing a channel.productChanges subscription. So anytime there's a change, specifically an update to the product catalog table, it's going to receive a notification, and it can then update the website to indicate that change. I need to make sure that there's a publication for real time on that product catalog. This is what will ensure that changes here are properly passed forward into the client. And now, if I go into side by side, the minute I turn this to true, they both update, right? So the beauty here is the database is instantly updating all the different clients listening to it. Now, it is possible that one of these subscribers might miss the message, right? There could be internet issues. So again, it's not a complete guarantee that the message is going to be delivered. And more importantly, is really oriented towards this pub sub model between the backend and the clients. So we've talked about Postgres Triggers. We've talked about database webhooks. We've talked about Supabase Realtime. Now there is another option called Listen Notify. And I really don't want to dig into Listen Notify because Supabase Realtime really takes Listen Notify out of the game. Basically, Listen Notify is pub sub for Postgres. You can set up a notification or trigger, and it'll then notify a set of listeners. Again, Supabase Realtime really takes that to the next level. So in the context of Supabase, you don't really need to think about it too much. So why did we create Sequin? Sequin adds some really nice features on top of these current options. First and foremost, it never misses an insert, update, or delete, similar to a Postgres trigger. But secondly, it provides exactly one's processing guarantees to the systems you're sending the message to. So this is a big benefit compared to all the others in that you can be sure that an order is processed and the message will be persisted and retried until it's processed. And third, it comes with a really nice developer experience. So there's observability and monitoring and ways to set up the distribution of messages to really meet your needs. There's routing, SQL filtering, transforms. There's a lot of really nice capabilities that we thought would make this paradigm really nice. So let me show you how it works. So let's go to the Sequin console and let's connect to our Supabase database. So let me go over to Supabase, project settings, database. Let me grab that connection string. Let me paste it in with the autofill. Perfect. Now we need to set up the slot. Sequin uses the wall to detect changes. Perfect. And now let me create a publication for its orders, right? Great. It's all healthy. So now let's create the consumer. So click add consumer, orders. We don't need to add any filters, though we could add filters if we wanted, which is a really nice feature here. We'll just do a changes consumer, though we can also do a rows consumer. We can talk about that more in another video. We'll do a push to replicate the Supabase. We'll give it a name, order processing guarantee, right? And let's have it go to the same webhook we were using before, just so we can get a sense of what the payload looks like. Great. Great. Now it's just telling me that we need to ensure that we're doing a full replica so that all the changes flow through. It's just one more SQL statement to run there. Perfect. If I come back here and refresh, errors cleared. We're all set up. It's just waiting for an event. So let's have a new order processed. Can you create a new order for me? Great. We have a new order. It'll come through. So if I go back to Supabase, execute that, we have order number 7. If I go to orders, we have order number 7. And if I go to the webhook, voila, we have the new webhook. So let's have this actually trigger the function. You can see the payload's a little bit different. So we will just trigger a slightly different function that can handle that payload. So if I go to edge functions, this is the function that can handle that webhook payload. And so let's just make sure that we create a consumer that triggers this endpoint. So I'm going to go and take this endpoint back over here. I'm going to We'll change the base URL. And because we're actually delivering it to a Supabase function, we need to add in a authentication header. Okay, so let's get a new order. Give me another order, please. Perfect. Let's take this order over to our database. Editor, paste that in, run it, ninth order, tables, orders, ninth order, go over here, consumer's running, let's check the trace. We received it, it's been delivered, perfect. Go over here to the edge function. We can see it's been invocated correctly. Great. So what are all the things that Sequin is giving me there? First, it's giving me this really nice UI to trace and see what's going on. I have a lot of observability, so easy to debug. It gives me these consumers that are highly configurable. So I can push, I can also do a pull consumer. I can do routing and max pending. All of that combined gives me a guarantee of deliverability, right? So that I can be sure that a message is actually received. I can do transforms, and I can really set myself up to start using my database as a stream of changes with exactly one's processing guarantees. So that's Sequin. It's another option of the 5. We're really excited about it. And depending on what you're building, pick the one that's best for you. If you're doing something simple that's really in the database, use a Postgres trigger. If you don't need exactly one's processing and you just want to send a webhook and hope it gets there, use database webhooks. If you're updating the client, listen notified, but more importantly, Supabase Realtime are great. And if you want exactly one's guarantee deliveries, use Sequin. Give it a try. We're around and we'd love to hear what you're building. The project is early, so reach out to us if you have any questions. Thanks so much.